Hello students, I'm Kashif Ibrahim and we are trying to understand different page replacement algorithm which happens whenever a page needs to be taken out from the memory and a new page is to be called from virtual memory. In previous lesson we have seen the first algorithm, that is first in first out, and we had a situation in which our whole memory is divided into three frames. We suppose that we had only three frames in the memory, frame number one and frame number two and frame number three. And we tried to analyze the situation in which when a sequence of pages are called by the CPU, then what happens and how a page is removed from the memory when all frames are filled. So because we had only three frames in the memory, we have seen that using first in first out algorithm and using this sequence of pages to be called, we had only three hits, page hits 1, 2, and 3, and we had 1, 2, 3, 4, 5, 6, 7, 8, 9 page miss or page faults. So we had page faults like we should page we had only three. So it may come in somebody's mind that if the number of frames are increased, then quite possible uh, we might have lesser number of page faults. So let's see this situation. We will see the same algorithm. What we will do, we will just increase the number of frames. Now in this situation, we have four frames in our memory, and these are the sequence, these are the pages which are to be called from the virtual memory. And first time, obviously, as you know that our all the frames which are available will be free. So first time page number one is called, and that will be kept in first frame. So this is page fault, that's why I put a cross here. Page fault means the page is not available, is not already there in the memory. Then page number two is required, that will be called from the virtual memory and will be kept in the next available slot, that is number two. Then page number three is required by the CPU. So in this situation, because all remaining frames are free, then that will be kept in the third frame. So this is situation number one, this is situation number two, this is situation number three. Now after this, fourth page is required, that is page number four. And because we have four slots in the memory, four frames in the memory, that fourth page will be kept here. Right now we have a situation in which all frames have been filled. Now what happens? As we are following first in first out algorithm, CPU requires page number one. So because we are following, uh, this is a page hit, page number one is already there in the memory, so we don't need to replace any of the pages. So this is a page hit and all of the frames will have the same data. After this, page number two is required by the CPU. This is already there, this is also a page hit, so no need to replace any of the pages. Then after this, page number five is required. As we know that because we are following first in first out algorithm, and the first page which is in the first frame came first, So this page will be removed from here, and this has been replaced with page number 5. Now we have first frame with 5 number page. After this page, CPA requires page number 1. This page will be replaced by second frame. In second frame we have page number 2, and rest of the frames will remain same. After this, page number 2 is required, so third frame will be replaced, this will be replaced, and 2 will be kept here, and fourth frame will remain same, rest of the frames will remain same. Then number 3 is required. In this situation, number 4 will be replaced. Frame number 4, which is having 4 number page, will be replaced with 3. After this, page number 4 is required here. So now in this situation, what happens? Because now frame 1 is having the oldest page, this will be replaced with page number 4. After this, page number 5 is required. Frame number 2 in this situation is having the oldest page, which came first. It will be replaced with page number 5. So now the whole program has been executed. All pages have been called from the virtual memory. Now let's see how many page hit and page miss we had. So number of faults, that is 10, and number of page hits, that is only 2. While in previous situation where we had only 3 number of frames in the memory, we had 9 page faults and 3 page hits in same situation. Here we have 10 page faults and 2 page hits. So this is called Balady's anomaly, right? So this is the end of this lesson. Inshallah, in next lesson we will try to understand the next algorithm. Thank you very much. Allah Hafiz.